This is Unit 2, question number 1. When we have absolute value, we need to do our positive side and our negative side. Positive side is 6x plus 4 equals 2, and our negative side is 6x plus 4 equals negative 2. We're going to solve them using the same steps, so we're going to subtract 4 from both sides. We get 6x equals negative 2, divide by 6, divide by 6. And we get x equals negative 1/3. Same steps here, subtract 4. 6x equals negative 6, divide by 6, and we get x equals negative 1. Problem B, 2x plus 1 equals 9, and 2x plus 1 equals negative 9. Subtract 1, 2x equals 8, divide by 2, x equals 4. Same steps here. 2x equals negative 9 minus 1, negative 10, divided by 2, x equals negative 5. And these are ors in between. Ors. Question number 2, solve and graph the inequalities. Same thing. 4x minus 2 is less than 3, and 4x minus 2. Now here we need to change the inequality symbol and the sign over there. Our steps are going to be the same. 4x is less than 5, divide by 4, divide by 4. X is less than 5/4. Or, same steps, add 2. Negative 3 plus 2 is negative 1, divide by 4, divide by 4. Or x, or all real numbers greater than negative 1/4. For B, same thing, 2x plus 4 greater than or equal to 2, and 2x plus 4 less than or equal to negative 2. Subtract 4. 2x is greater than or equal to negative 2, divide by 2. All real numbers greater than or equal to negative 1. Subtract 4, 2x less than or equal to negative 6, divide by 2, x is less than or equal to negative 3. So we're less than or equal to negative 3, and we were supposed to graph this, so here's our graph, and I've got negative 1, negative 3, and negative 1. We're going to be greater than or equal to negative 1, and less than or equal to negative 3. So this is an OR graph, so that's right there. All right, on this next one, when I graph, I've got negative 1/4 and positive 5/4, and we are less than 5/4, and we're greater than. So this is actually an and, so I want to change this to, this is not an and, or it's an and, so I want to change it, so I need to write it in order. Okay, in order, our numbers would be negative 1/4 and 5/4. Put our x in the middle, and then pay attention up here to what we're eating. Okay. All right. Between the x and the 5/4, we were eating the 5/4, so I continue doing that. Between the x and the negative 1/4, I was eating the x. So now that's how we'd read that, as all real numbers greater than negative 1/4 and less than 5/4. Question 3, determine which of the following are functions. Remember our vertical line test. So if we draw a vertical line, how many points does it go through? This goes through 1. This goes through 2. This goes through all of them. This goes through 2. So we want, which one would be a function? The one that just goes through 1, because there's only one input, or for every input, there's only one output. We're going to call this question 3b because we've already had a 3. So 3b, which of the following tables represents a function? For a function, for every input, it needs to have only one output. So when we input a 1, we get out a 3. Input a 2, we get out a 4. Input a 3, we get out a 6. Input a 2, we should get out a 4, but it's 7. So this is a no because of that 7. should be a 4. 0, 1, 1, 2, negative 1, 3, 3. This one's good. For the next one, 3, 5, 4, 6, 3, 4, right? So 3, this should be a 5, right? So that one's no good. No. And 2, 1, 1, 2, 3, 1 should be 1, 2 here. So that's a no. Question 4, given g of x equals negative 3 times the quantity x plus 5 minus 1, solve for g of 4, g of negative 7, and g of negative 1. So here's our equation, negative 3 x plus 5 minus 1, right? And we're going to substitute in this case, it's our negative 4 because there was an x right there. So we're going to say negative 4. And we're going to solve this. So I do what's inside. Negative 4 plus 5 is 1. So negative 3 times 1 minus 1. Negative 3 times 1 is negative 3. Minus 1 is negative 4. So I'd say g of 4 equals negative 4. Same thing here for negative 7. Okay, we're going to have our 5 minus 1. And here we're substituting in our negative 7. Do what's inside first. Negative 7 plus 5 is negative 2. Negative 3 times negative 2 minus 1. Negative 3 and negative 2 makes 6. 6 minus 1 is 5. So g of negative 7 equals 5. And our last one, negative 3, leave our space, 5 minus 1, and we're going to substitute in a negative 1. Negative 1 plus 5 is 4. Negative 3 times 4 is negative 12, minus 1 is negative 13, so g of negative 1 equals negative 13. We're going to call this 4b. What is the domain and range of the relation? So domain is all input values, so the domain would be 1, 2, 3, 5, 6. So 1, 2, 3, 5, 6, that's the domain. And the range is the output values, 2, 5, 0, 7, negative 1. 2, 5, 0, 7, negative 1. Question 5, a function is defined as f of x equals negative 3x squared plus 2x minus 5. What is f of negative 1? So let's rewrite this. We'll leave parentheses where our x is, and we're going to substitute in this negative 1 inside those parentheses. So first thing we need to do is we need to square this. So negative 1 squared, negative 1 times negative 1 is positive 1. So this is negative 3 times 1 plus 2 times negative 1 minus 5. Next step would be to multiply. Well, negative 3 times 1, or 2 times negative 1. So first, negative 3 times 1 is negative 3. 2 times negative 1 is negative 2 minus 5. And now negative 3 minus 2 is negative 5. Minus 5 is negative 10. So I'd say f of negative 1 equals negative 10. Question 5, we're going to call this question 5b too. Determine the domain and range of the relation. Is it a function? So input, output, input, output, input. Okay, so the domain is all the input values. So the domain is 1, 2, 3, and 4. And the range is all the output values. So 4, 5, 6, and 7. And is this a function? Yes, because for every input it has one output. Question 6, which input-output table represents the function 2x minus 4? Well, let's try using some of these inputs. So when we input a 1 into our function 2 minus 4, and I'm going to input this 1 here. Let's see what happens. So when I input a 1, I get 2 times 1 is 2 minus 4 is negative 2. So this one works. So this one doesn't work because I got 2. This one doesn't work because I got 6, and this one doesn't work because I got a -3. So it has to be this first one. Okay, we can do 7 a couple different ways. The first way is by using our explicit rule, right? So our explicit rule says A of n equals the first term plus n minus 1 times our d, and d stands for the common difference. So what is our common difference? From 9 to 11, we've got a difference of 2. From 11 to 13 is 2. So our common difference is 2. And so we're just going to plug stuff in. Our first term here is a 9. So 9 plus n minus 1, and our common difference was 2, so times 2. And now we just simplify this from here. We've got to distribute, so this makes 2n. 2 times -1 is -2. The 9 from up here we can't forget about, so we get 2n plus 7. So it looks like A. The other way to do it is to plug in our input. So if I plugged in an input like 1 into this, if I plugged it in here, 1 would be, into 2n plus 7, so it would be 2 times 1 plus 7. Well, 2 times 1 plus 7 is 2 plus 7, which equals 9, and that was our output when we inputted a 1. Now if I plug in a 1 into this one, it would be 1 plus 2, that doesn't equal 9. 1 plus 8, this does, but if I plug in a 2, my next number, 2 plus 8, doesn't equal 11 like it says it should. And the same thing with D here. When I plug in a 2, 2 times 9 is 18, not 11. Question 8 wants the first 5 terms of the sequence. So we've got our first term that should be A of 1 equals 2 over 1 minus 4, which equals 2 over -3, which is -2/3. A of 2, 2 over 2 minus 4, which is 2 over -2, which is -1. Third term is 2 over 3 minus 4, 2 over -1, which equals -2. Fourth term is 2 over 4 minus 4, 2 over 0. Anything divided by 0 is undefined. Undefined there. And the fifth term is 2 over 5 minus 4, which is 2 over 1, which equals 2. Question 9, write the explicit and recursive rule for the sequence. So let's find out a little bit about it. Looks like it's going down by 6 each time. All right, so our general form of our explicit rule is A of n is the first term plus n minus 1 times d, where we need our first term, which in this case is 28. So 28 plus n minus 1 times our d, which in this case is -6. Now I'm multiplying, so I make sure I put that in parentheses here. So now I've got to distribute, so this makes -6n, and distribute again, plus 6, and don't forget about the plus 28. So my explicit rule is -6n plus, what is that, 34. And my recursive rule, remember the general form of the recursive rule is just the previous term, so A of n minus 1 plus d, right? So our common plus our common difference. So all we need to do is say it's A of n equals A of n minus 1, and then in this case it's -6 because my d was -6. Common difference was -6. 10, write the explicit and recursive rule, so same thing as question 9. The explicit rule, A of n equals A of 1 plus n minus 1 times d. We need to know our common difference. So our common difference here, negative 28 to negative 37, looks like we're going down by, what is that, down by 9? 37 minus 28 down by 9. 37 down by 9, down by 9. So our d is negative 9. Our first term, negative 28, so negative 28 plus n minus 1 times our d, which was negative 9. And then we're going to distribute. So that makes negative 9n. Negative 9 times negative 1 makes positive 9 minus 28. So this is negative 9n minus, 19? Minus 19. And so this is our explicit rule. Our recursive rule, again, is our previous term plus d. So in this case, it's just a of n minus 1 minus 9. Recursive rule, pretty easy. Question 11, given the sequence, find the common difference, the explicit rule, and a of 20. So the common difference looks like we're going up by 5. So common difference, d equals 5. There's 1. The explicit rule, right, a of n equals the first term plus n minus 1 times d. So we need our first term, which in this case was 15. So 15 from above plus n minus 1 times 5, because our d was 5. And now we're going to distribute. So I get 5n minus 5 plus 15, 5n plus 10. So here's our explicit rule. And then we want the 20th term. So if 20 is going to be, we're just going to plug in a 20 into 5n plus 10. So 5 times 20 plus 10. 5 times 20 is 100, plus 10 is 110. So that means that our 20th term is going to be 110. 12, same thing as 11. Find the difference. So the difference from negative 18 to 11 looks like we're adding 7. Negative 11 to negative 4, we're adding 7. So our common difference is 7. The explicit rule, if n equals our first term plus n minus 1 times d. So we're going to plug stuff in. Our first term here is negative 18. So negative 18 plus n minus 1. And our common difference is 7. So we're going to distribute. I get 7n minus 7 minus 18, 7n minus 25. So our explicit rule is there. And then the 20th term. So we're going to plug in a 20 here. So 7 times 2 is 14, so 7 times 20 would be 140 minus 25. So our 20th term looks like it would be, what is that, 115? 13, using an input-output table, graph the arithmetic sequence, negative 3n plus 4. So let's use inputs of 1, 2, 3, 4, and 5. So when I substitute in a 1, it's negative 3 times 1 plus 4, which is negative 3 plus 4, which is 1. So I've got the point 1, 1. It's our first one. To the next one. Negative 3 times 2 plus 4 is negative 6 plus 4, which is negative 2. So 2, negative 2. 2, negative 2 would be right there. Our next one, negative 3 times 3 plus 4 is negative 9 plus 4, which is negative 5. So 3, negative 5 right there. And we can tell that it looks like we're going down 3 each time, right? So negative 3 times 4 plus 4 is negative 12 plus 4, negative 8. So 4, negative 8, 6, 7, negative 8, somewhere in there. And the next one would be, if we're going down by 3, should be what? Negative 11. So 4 or 5, negative 11, down another 3. So the domain is all the inputs, so 1, 2, 3, 4, and 5. And the range is all the outputs, 1, negative 2, negative 5, negative 8, and negative 11. 14 through 16. 14 lists the ordered pairs of the relation. So the ordered pairs are 1, 3, negative 2, negative 4, 5, negative 2, and negative 4, 6. Okay, plot the ordered pairs of the relation on the coordinate plane. So 1, 3, 1, 3, negative 2, negative 4, 5, negative 2, and negative 4, negative 6. And is the relationship a function? Yes. One for every input, there's one output, and it passes the vertical line test. So it passes vertical line test, and every input has exactly one output.